Everyone, my name is Kelly Ilsman and I'm here at the University of Maine in Orono representing the Upward Bound Math Science program, which serves qualified students who are interested in STEM, college majors and careers. I wanted to tell you a little bit about our group design project, which is part of our summer curriculum. We worked with Maine EPSCoR, Sustainability Solutions Initiative, graduate students and faculty, as well as the Foster Center for Student Innovations. Christine Hoffman was my partner in this endeavor, and she embarked on this adventure with us to offer her problem, which was finding a suitable salamander trap so that she could complete her research.
My name is Christine Hoffman. I'm a graduate student in the University of Maine's Department of Wildlife, Fisheries, and Conservation Biology. I study vernal pools for my research. Vernal pools are wetlands that dry up seasonally every few years, and because of that, fish can't live in them, so they're good places for amphibians to breed.
So the relationship that Upward Bound Math Science has with Maine EPSCoR is really unique, but any science teacher can contact faculty on a university campus close to them to form a partnership.
To be able to work with the salamanders, I need to get my hands on them. And that's where Upward Bound came in. They approached me and asked me if I needed an invention that the students would be able to produce, and I thought the salamander traps would be a great thing for them to work on.
I had 5 different faculty members present problems that they were facing in their research that they felt could be solved with a student invention or an innovation. And then student groups got together for a few minutes after each presentation and brainstormed what they thought would be a viable design for that particular problem.
I study the blue-spotted salamander and the blue-spotted salamander complex. There's a unisexual salamander in that complex, which is a salamander that the entire species is all female, and to reproduce they need to steal sperm from a different species. The only way to tell these two species apart is using genetics. So I need to catch animals and take DNA samples to be able to see what species is which for my research. This is the traditional trap that we use to catch salamanders when they're in a wetland. This is a minnow trap. It's commercially available. It has a funnel on both ends, and we put it in unbaited. The salamanders are crawling around looking for mates, and they're moving all over the pool. When they're crawling along, they hit the funnel, they go on into the hole, and then they're captured until we come by and let them out. The problem with this trap is that it's only about a foot tall. If I throw this into the middle of the wetland where the most salamanders are, where it's nice and deep and they're congregating, any animal that gets caught in this isn't going to be able to reach the surface and take a gulp of air until I let them go. And so this can drown salamanders, and I can't do my study if I'm going to be killing animals. That's against the whole conservation.
So ultimately, 4 out of the 5 groups ended up choosing Christine's Salamander Trap Challenge to work on throughout the summer. And when Christine and I discussed why that may have been, we felt like there were a few different reasons, but primarily was the clear list of criteria and constraints that she offered to the students.
They fold up, they can be flat, they can be squishy, but they have to be relatively light. They can't be 100 pounds each, so they can be easy to transport. They have to be cheap to make. I only have $600 to make these, and I have to have 100 traps. So that's $6 per trap. You have to be able to rest on the bottom of the pool. You can't put them in the water and let them float on the surface. If they float on the surface, they're not going to work. Allow the salamanders to breathe. And they have to have a relatively small mesh on them. A lot of minnow traps are made with things like chicken wire, but that will allow the salamander to just swim out. And it has to be able to funnel the salamander so that they can get to the surface.
And then the cones, if they just stack, then you don't have to worry about trying to make flat. Which, I mean, it's not that hard, but it's a little tricky because you have more you have to be more precise than a square. You can make it a little bit easier.
After each faculty presentation, when student groups got together to determine what they thought would be the best solution to each of those problems, we went to the Foster Center for Student Innovation At the Foster Center, student groups really vetted each of those ideas and decided as a group which problem that they would work on for the rest of the summer.
What have you guys decided on doing?
We're doing the Salamander trap.
Yeah. What made you choose that?
Well, it was kind of like a unanimous thing. It's almost like everyone just like we're doing Salamander.
We encourage group facilitators to use the process of facilitative leadership, which is really looks like in practice looks like guiding students through discussion and decision making together. So students are working on social skills, and they're also working on decision making and leadership, sharing ideas, and it really helps them invest in the process and the final outcome. Jessie Darkus, who was the leader for the Confused Kangaroos, that group had the design that was largely the basis for the design that Christine ended up producing and using in the vernal pool the following spring. Jessie said that the most important thing for her was student observation, just plain getting to know her students. And that way she could observe their strengths and some of the challenges they had working as a group, and was in a better position to guide them towards project completion. They had freedom within boundaries, which was important for their developmental stage as well as the short time frame of our summer program. So it was an environment we hope to foster. It was a safe environment for student failure and then getting back up again and saying, okay, well, that didn't work well. What do we need to change here in order to make this work and progress in the direction of our final design? So it spurred creativity, and it spurred them to look for information or find information when they needed it.
So my study would not have taken place if Upward Bound students hadn't come up with a replacement trap for me. This trap is tall enough to be able to allow animals to come up, get a gulp of air, and then swim back down. Because even in the deep section of this pool, it's going to be about here, the top is above water. So then I can ask questions like, are they always occurring at the same spot? Do they compete so that they're in different areas? Is one species more common than the other species? And I can start getting at the ecology. When you approach your researchers, they're naturally going to be thinking, what's in it for me to do this collaboration? And while I can't answer for every potential researcher out there, I do have a list within the manuscript of reasons that I wanted to participate in this project. And I've got the list here as my cheat sheet. So first was the outreach potential. I already try to do a lot of outreach to engage the public and have them understand what a vernal pool is, and here I have this nice captive audience. Second is that it saves time for me. I wasn't gonna have to sit down and draw out all these different ideas and then try to create and think through the project, because the students were gonna do that. The students were unbiased by historic traps. In my head, I know what a salamander trap is supposed to look like because I've worked with them for years, but the students don't have that, so they can think outside of the box easily and give me something novel. And then the fourth one is just that they gave me a tangible prototype. This tangible trap, I was able to hold it up and say, okay, here's a weak point or here's a strong point, and incorporate that into my future designs. So it was very worth it for me personally to be on this project.
So as teachers begin to consider how they might adapt this project for their classroom, Christine and I wanted to emphasize this is a creative process. It's an organic process. That's part of the fun of this project and part of the reason that it had such a successful outcome. We were just really excited that we could take part in a project that had an impact on scientific research here at the university, and our students were responsible for that. Hope you enjoy. Thanks.